Okay, well, we're trying to fit into the equation of motion. The equation of motion that we've been using is y equals a cosine of omega t plus theta naught. Could have used sine here instead of cosine. We'd have gotten a different theta naught, or we would get a different theta naught once we solve it. But then, of course, the equations for velocity and acceleration follow immediately by taking successive derivatives of the position function. Now, where are we with this solution? Well, first of all, see where we could have been. We could have used our initial conditions. V of 0 equals negative 6 meters per second, y of 0 equals negative 0.15 meters with selected equations here. We'd have had two equations using which we could calculate the unknowns, which are a and theta naught. So that would have been a perfectly valid approach to the problem. We chose an alternative mainly for the purposes of illustration and to give you another tool in your tool chest, where we used the given information to directly find the amplitude using energy considerations. So our situation here is we don't need to use both of these initial conditions. All we need to use is one of them along with our knowledge now of the amplitude, because the only things we don't know, well, let's look at what we do know. We know A, we know omega. Okay, so of course we know A and omega here, and we know omega and A here, so I've got little check marks over everything we know. The only thing we don't know for this side of the equation is theta naught. So you should, if you haven't already thought it through, I'm going to switch out boards here, but you should think through how we can use the conditions that we're given in order to determine theta naught. You have two choices, actually. I'm not going to tell you what they are. There are two possible ways you can do this. One way is a little simpler than the other, but either way would get you there. So we're going to pause for a second and let you think about that. Okay, we're going to proceed. I think the simpler choice is to use the y condition, and we have this equation so that y of 0 would equal A. Now we know A to be 0.35 meters. That's not an exact solution, so we're not going to get exact consistency. You can get the exact solution and check consistency as you wish, and you probably should do that. I didn't need parentheses there, now I got a streak on the board, but that's okay. Okay, that would be times the cosine of 20 radians per second times 0 plus theta naught, substituting 0 for t. Now that then equals 0.35 meters times the cosine of theta naught, and that's negative 0.15 centimeters, 15 meters, 0.15 meters, okay? Well, that tells us then that the cosine of theta naught is negative 0.15 meters over 0.35 meters. That's going to be negative. Now let's see, that's 3/7 and 0.43 approximately. Okay, that's approximately negative 0.43. That's our cosine of theta naught, so the theta naught is the inverse cosine, approximately equal to the inverse cosine of negative 0.43. Okay, so that's perfectly good. Now you can calculate that with your calculator. We'll estimate that just to reinforce unit circle reasoning and so forth, and we'll do that in a minute, but let's go on and see what would happen if we'd used our initial velocity as a condition, because if we get an angle theta naught that's not within round-off error and so forth, an approximation error, consistent with this, we've got a problem. Okay, well, so let's see. V of 0, well, we just substitute 0 into this equation, and that's going to give us negative omega A times the sine of theta naught. Now, omega is 20 radians per second times our amplitude, which is 0.35 meters, times the cosine, and I said cosine, but it's a sine of theta naught. You can work out the details. 20 times 0.35 is 7. So that sine of theta naught equals, and that's 7 meters per second times the sine of theta naught equals -6 meters per second. Okay? So that the sine of theta naught should be -6/7, meaning that theta naught should be the inverse sine of -6/7. Now, is the inverse sine of -6/7 equal to the inverse cosine of -0.43? Of course, you could figure those out in your calculator, but you don't need a calculator to check this and verify it. The sine squared plus the cosine squared of an angle has to be 1, so if the square of this plus the square of this is 1, then we've got it. Now, having said that, it's not all that close. 6/7 is like 0.86. If we square 0.86, we get something like 0.7, and 0.43 squared is like 0.2, and that adds up more like to 0.9 than it does to 0.1. So there's something wrong there, and I'm going to leave it to you to figure out what it is. These are not too far apart. I really suspect that my approximation here is off. It is off, but 3.5 squared is 11, and well, it's like 11 1/4, isn't it? Okay, well, you figure it out. Figure out what I've done wrong here. There's something wrong in this thing, but as I say, it won't hurt you to figure it out. If you can't reconcile it, get back to me and we'll reconcile it together.